right, when you take a look at these opposite angles in a quadrilateral, you are going to find that they add up to 180, which means if they add up to 180, what term would refer to that? They're supplementary. Okay, so these opposite angles are supplementary only if they're inscribed in a circle. If they're just regular quadrilateral, there's no other restrictions on it, then there's no specific relationship other than all the angles add up to 360. But if they are inscribed in a circle, let's take a look at this. So we want to find what's the relationship between angle W and angle Y. Okay, so if we look at that, we can identify specific relationships about each of these angles independently. Angle W is an inscribed angle. Its vertex lies on the circle. So it's going to be, in terms of this intercepted arc, its measure can be represented how? 1/2 the measure of the entire arc that it's intercepting. So x, y, z. And I'm going to label it with 3 points because I don't know if it's a major or minor arc necessarily. And I can also find angle y. Angle y also is an inscribed angle. Its vertex lies on the circle. And it's going to intercept this entire arc from x through w all the way back to z. So the measurement for angle y is 1/2 the measure of the intercepted arc x, w, z. So if we look at this, the total sum right here, we can go ahead and calculate replacing 1/2 the measure of x, y, z for w, and angle y we can replace with 1/2 the measure of x, w, z. Now between these two terms we can remove a common factor of 1/2, leaving the arc measure x, y, z plus x, w, z. Well, when you look at this, here's x, y, z. Here's x, w, z. So together they form a what? A full circle, which is how many degree rotation? So this whole thing is 360. And so if we're taking 1/2 of 360, we get our answer to be 180. So opposite angles of a quadrilateral inscribed in a circle are always going to add up to 180 degrees.